These are notes for nuclear chemistry worksheet number 2. Half-life. The time required for 1/2 of the nuclei in a sample to decay. Examples. Iodine-131 is used to treat thyroid cancer, has a half-life of 8.07 days. Uranium-238 has a half-life of 4.51 billion years. Carbon-14 has a half-life of 5,700 years. Lead-210, 22.3 years. Potassium-40, 1.26 billion years. Sodium-24, 15 hours. Magnesium-27, 9.5 minutes. Iron-59, 46.3 days. And you can keep reading through these and see what their half-lives are. Some are ginormous, and some are not so big. For example, smoke detectors use americium, which has 432 years for its half-life. Other half-life examples, we've got chlorine, we've got tritium, oxygen 18, potassium 42, chromium 51, and on it goes. So half-life formula, you can think through the problems that we're going to do, or you might be able to use the following formula. The amount undecayed equals the original amount times 1/2 to the n, where n is the number of half-lives that have occurred. To find n equals the time elapsed times 1 half-life divided by the length of the half-life. Let's do problem number 1 from worksheet 2. Let's see how successful we're going to be with writing today. Is it on there? So, problem number 1 from worksheet 2. It says, if a 100-gram sample of gold decays for 8.10 days, how much of it remains in grams? The half-life is 2.70 days. So the first thing I would do is say we have 8.10 days and divide that by, there we go, 2.70 days per half-life. I'm going to write HL for half-life. So you get days cross-canceling, and since half-life is on the bottom of the fraction, it's going to flip up to the top, and what we're going to get is 3 half-lives. So we have 3 half-lives. So step number 3, I'm going to take a look at this. I'm going to do a little bit of inspection. So we started with 100 grams. If we cut that in half, we'd have 50 grams. If we cut that in half, we'd have 25 grams. And if we cut that in half, we'd have 12.5 grams. So I'm going to count the half-lives. There's 1 half-life. There's 2 half-lives. Aha, there's 3. Whoops, that's a big 3, isn't it? There's 3 half-lives. So it asks us, after 3 half-lives, how much remains? It didn't ask us after 3 half-lives. It asked us after 8.10 days, which is 3 half-lives. So we would have 12.5 grams left after 8.10 days. Now we're going to do problem number 3 from worksheet 2. This says a 50-gram sample of nitrogen, which is 16/1. Let's see if we can write this in there. Nitrogen, I don't think it really matters, which is 16/1. That must be, what is nitrogen? Anyway, decays to 12.5 grams in 14.4 seconds. What is the half-life? So first of all, just take your number. I'm going to write this one down a little bit lower. And let's say we were to double it. 12.5 doubled is 25 grams, and that would be 1 half-life. Let's say we doubled again. We would get up to 50 grams. That's 2 half-lives. Well, look at that. This number is what we started with. A 50-gram sample decays to 12.5 grams in 14.4 seconds. What is the half-life? So, I did a little bit of investigation there and a little bit of thinking about it. And I'm going to say, half-life. What is half-life? Half-life is time per half-life. And in this one we have seconds, so our time could be seconds. So what if we did 14.4 seconds divided by 2 half-lives? That would give us 7.2 seconds per 1 half-life. Huh, that's the answer. Ta-da! Now we're going to do problem number 5 on the next page, but still worksheet 2. The half-life of thorium-232 is 1.4 times 10 to the 10th years. If there are 25 grams of the sample left, so that's at the end, after 2.8 times 10 to the 10th years, how many grams were in the original sample? And this one looks very interesting. Whoa, back up, buckaroo. There we go. I'm going to start with 2.8. I'm just going to write e to the minus 10 years. The units are always so important because it helps you investigate what you're doing. And we know we have 1.4 e to the positive 10. Why did I put minus 10? That's positive 10, sorry. E positive 10 years per half-life. Again, we get these years canceling out, and that half-life flips up to the top. That gives us 2 half-lives. We have 2 half-lives have happened from those numbers. And so now I'm going to say that we started with, we ended with 25 grams, so let's work backwards. 25 doubled is 50. That's 1 half-life. And let's say we double that. That would be 100 grams, and that would be 2 half-lives. 2 half-lives. So we started with 100 grams of material. That's what we started with before it decayed. And that's all she wrote.
Final blessing. Teachers, please prepare for our closing blessing.
And that's the end of our notes for worksheet 2.
In the name of the Father, and the Son, and the Holy Spirit. Amen. May the Lord bless you.